All right, so this will be probably our last video for this chapter, and it's going to cover how to convert between different units of temperature. And when doing temperature conversions, you need equations. Okay, so they're not quite as straightforward as doing unit conversions. You actually need an equation to convert between the different temperature systems. So the most common systems are Celsius, Fahrenheit, and Kelvin. So in science, in chemistry especially, Celsius and Kelvin are the most common. And Kelvin happens to be the SI unit for temperature. And I may or may not have mentioned this before, but SI units are the international standard for temperature. So the International Union of Pure and Applied Chemists, which is an acronym that makes IUPAC, is the governing body of all things chemistry around the world. And they have decided that the standard unit for temperature is Kelvin. Other common things are Celsius, and less common are Fahrenheit. Pretty much the United States is the main place where you'll find Fahrenheit temperatures. But anyway, so to get into this, let's talk about a few how these different systems relate. So water boils at different temperatures. Well, it boils at the same point, but the numbers are different between the different temperature systems. So degrees Celsius, water boils at 100 degrees. That's pretty easy to think about. In Fahrenheit, we get water boiling at 212 degrees Fahrenheit. And in Kelvin, it's 373. Right, so water freezes. In Celsius, it freezes at 0 degrees Celsius. Freezes at 0, boils at 100. Why we don't use that in this country, couldn't tell you. But that's what it is. Freezing point in degrees Fahrenheit, 32. And in Kelvin is 273. Now notice that Kelvin, between boiling and freezing, is the difference of 100. In Celsius, between boiling and freezing, is the difference of 100. The only difference is they are offset by 273. So the easiest conversion is Celsius to Kelvin, or vice versa. Okay, so Kelvin temperature is degrees Celsius plus 273. Super easy. So if you have to convert from degrees Celsius to Kelvin, our temperature in Kelvin will just be 25 plus 273. So the temperature in Kelvin is 298. Right? Celsius to Kelvin is the easiest one. Plus or minus 273 depending on which direction you're going. Celsius and Fahrenheit is a bit trickier. Celsius Fahrenheit conversions, height, require equations. So if you want to know the temperature in Celsius, your equation looks like this. You have your degrees in Fahrenheit minus 32, and all of that divided by 1.8. Okay, it's important to use those parentheses. Determine that Fahrenheit minus 32 first, then divide by 1.8. If you need to convert 2 degrees Fahrenheit, we have 1.8 times degrees Celsius plus 32. No parentheses to worry about. right? So just as to do some examples. Let's say I want to take 96 degrees Fahrenheit and convert that to degrees Celsius. So I'm going to use my top equation and find degrees Celsius. So I'm going to say degrees Celsius equals my temperature in Fahrenheit, which is 96, minus 32 divided by 1.8. So my degrees in Celsius should come out to be 36 degrees Celsius. On the other end of the spectrum, so let's say I have a temperature of 22 degrees Celsius, and I want to know what that is in Fahrenheit. So degrees Fahrenheit equals 1.8 times my degrees Celsius, which is 22, plus 32, means a nice comfortable temperature of 72 degrees Fahrenheit. Okay. So to continue on with our slides, so question 36. The human body has an average temperature of 98.6 degrees Fahrenheit. What is this temperature in Celsius? So our equation, if we want to know what degrees C is, the equation is degrees Fahrenheit minus 32 divided by 1.8. So give this video a pause, see if you can calculate the temperature on your own. So degrees Celsius equals our degrees Fahrenheit 98.6 minus 32 divided by 1.8 comes out to be 37.0 degrees Celsius. And the slide tells us we're correct. Yay! All right, so this particular slide is pretty easy. How do you read a thermometer? So if we have 10 degrees here and 15 degrees here, each one of those lines in between is 1 degree. And our thermometer, the red liquid inside the thermometer is sitting right on the line. No guessing whatsoever, up or down. Exactly 13.0 degrees Celsius. Now this question 38 here is really kind of a challenge question. It's a bonus question. Okay, so reading through this, it may seem like a lot of words and it may seem really intimidating, but I'm gonna try to help you to sort of suss out what is the important stuff. Now, the truck you have has a volume of 30,000 liters. And empty, the truck by itself, let me change to a more vibrant color here. Empty, the truck by itself has a weight of 15,800 kilograms. Okay, that's the truck by itself, empty. All right, now the route that we wish to travel, there's a bridge that has a weight limit of 25 tons. Now, if we purchase the truck and we fill it to capacity with a liquid that has a density of 0.8 kilograms per liter, that's a density, will it be too heavy to cross the bridge? Okay, so we're talking about density. We're going to use density to figure out how much the truck weighs. Right? So what is the weight of 30,000 liters with this density? And then we have to add it to the weight of the truck. Okay? So the first question is how much does the liquid weigh? Right? So I'm going to scroll down to a full open page because there's a fair amount to do with this problem. So the first question we have is, what is the weight of 30,000 liters? That's the volume of the truck. What is the weight of 30,000 liters of 0.80 kilograms per liter liquid? Okay, and that's the first thing we know. In order to know whether the truck will be able to pass, we need to know the weight of the liquid plus the truck. Okay, we already know the weight of the truck, so we need to know the weight of the liquid, and we're going to use the density to find that out. So 30,000 liters, and we're going to use the density as a conversion factor. All right, so our liters will cancel out and give us an answer in kilograms. So this comes out to be 24,000 kilograms. So the weight of the liquid plus the truck is 24,000 kilograms for the liquid. The truck itself, empty, weighs 15,800 kilograms. So we have a total weight of 39,800 kilograms. Right now, here's the other tricky part. So let's come back to our question here. So the max weight of the bridge is in tons, not kilograms. So we need to make our units match. All right? So let's convert the truck to pounds, and then pounds to kilograms. Okay? So we have 25 tons is the weight limit of our bridge. So we need to know what that is in pounds. All right? And there are 2,000 pounds per ton. Again, using the unit conversion factor tactic. So the tons go away. So we have a max weight of 50,000 pounds for the bridge. Right? So the truck, we have 39,800 kilograms for the truck and 2.20 pounds per kilogram. Means that our truck weighs 87,560 pounds. So if that truck goes over the bridge, we have a disaster. We have to call in emergency teams and rescue teams and all kinds of things, and probably environmental teams and all sorts of things. So this was a challenging question. This last question was very much an advanced question. So I hope you gave it a try and sort of tried to reason it out, and with any luck, you were able to figure out that the truck would wreck. So that does it for the Chapter 2 lectures. I hope you've enjoyed it, found it useful, and filled out your lecture worksheet along the way. And I will see you in class soon. In class meaning in Zoom soon.